Okay, guys. So we're going to do a set of notes here that has to do with using equations for when we throw an object up. So we're going to call this, so the topic here, let me zoom in a little bit so my handwriting doesn't suck. We're going to call this equations for thrown objects. Equations for thrown objects. And now my essential question is going to be, how can I use motion equations to calculate that looks bad. Calculate. Let's go down here. How can I use motion equations to calculate velocity? Sorry, guys, I'm having a bad writing night here. Velocity, time, and height. Okay, so we're going to use the exact same equations that we used for a dropped object, but we're going to use them just a little bit differently. And before we do anything else, I think there's one really big point that I want to make here before we go on. And so we're gonna so this will be like important. All right, so the important note is that it takes an object the same, here we go, amount of time to come down as it did to go up. And I'm going to highlight that in red because I think that is super duper. That's right, I said super duper. Super duper important. It takes an object the same amount of time to come down as it did to go up. All right, so let's think about that. If Mr. McSparron is standing here and he throws the basketball up and it comes back down, and let's say that it takes 2 seconds to go up to the top, it's going to take 2 seconds to come down to the exact same spot that it was thrown from. So the total amount of time would be 4 seconds that it took to go up and then back down to where it started from. And if we were going to let it fall to the ground, then it would take a little bit more time. But to get back to where it started from is going to take the exact same amount of time. That's going to be really important on a couple of these. And hint, it's important for the test. Important for the test. All right, so make sure that you highlight that. Okay, so let's get into some of our equations. So the first equation that we used was this. We used VF equals VI minus 9.8 times delta T. And we're going to use that one again. So let's just go ahead and on your sheet, box that in. If you happen to have a highlighter, go ahead and highlight it because it's going to be important for these just like it was important for the previous ones. Okay? And so there's a couple different ways that we might use this. And so we might be able to do this. So like the first thing we can do is let's calculate how long it takes to get to the highest point. Okay, so let's think about this, all right? So let's just say that I told you that VI, so if I if I said that VI equals, oh, let's just say 15 meters per second, okay? And I wanted to figure out how long it takes to get to the highest point. Well, that would mean that I'm trying to figure out delta t because it says how long. Okay, so I'm trying to figure out delta t. They gave me VI. And so let's just go ahead and so we're organized better. Let's put delta t like right here, okay? And now the other thing I need is I need VF. And let's think about that. So the final velocity that we're trying to get to here is the object at its highest point. So let's think back to the lab. And on the lab, one of the questions was, what is the velocity at the highest point? And you should have written this, 0. So remember, when an object is thrown in the air, when it reaches its highest point, for a split second, it's not moving anywhere. It's not going up, it's not going down, and so its velocity is 0. I like to think of it, and I told you guys some of this, I like to think about it at Worlds of Fun on the detonator. When you ride the detonator, right? And, you know, the detonator kind of looks like that. And you go up to the top, and then it starts to come back down, and just for a second, you hang in the air, okay? And that's that same thing as an object being at the top of its or the top of its path. So at the highest point, it hangs free in the air. It doesn't go up, it doesn't go down, and so its velocity is 0. So now we can just plug stuff in. So I have VF equals VI minus 9.8 delta t. And so I'm going to take it, I'm going to plug in my VI. I'm going to plug in my VF, and so I'm going to have 0 equals 15 minus 9.8 delta t. And now this just becomes an algebra problem. So remember, I'm trying to solve for delta t. And remember that delta t right there, you can treat delta t just like it's an x in your math class. So the first thing I want to do to try and get delta t by itself is to get rid of this 15. So to get rid of the 15, notice that the 15 is, technically it's being added to a negative 9.8 delta t. So to get rid of it, we're going to have to subtract 15 from both sides. Okay, so I'm going to end up with negative 15 equals negative 9.8 delta t. Now, the last thing I need to do here to get delta t by itself is just to divide by negative 9.8. Okay, and now we're going to have delta t equals, and what I'm going to have to do is I'm going to do negative 15 divided by negative 9.8. Now what you're going to see me do here, it's going to be a little tricky. I'm not going to use the negatives because I already know that a negative divided by a negative equals a positive. So when I put it in my calculator, I'm not going to put the negatives in, so don't freak out. Oh man, what was that all about? What is wrong with my computer? 1. Why won't it do 1? 1. Okay. 5 divided by 9.8. And we're going to get 1.53. So that means that it's going to take 1.53 seconds for the ball to get to the top, to the highest point, the top of its path. Okay, good. So that's sort of the first thing we can do. Calculate how long it takes to get to the highest point. Okay, now the next thing we can do, let's do a 2 here, and then I'll zoom in. Okay, I can also do this tricky thing here where I can calculate, let's see, I can use this same equation to calculate the initial velocity. Okay, so let's say now that what they gave me, okay, what they gave me was that delta t, the time it took to get to its high. Oh my gosh, holy cow. I'm sorry, guys. All right, so I'll give you guys a second. My bad, I didn't realize I didn't flip back. So calculate initial velocity. So you guys go ahead, pause it if you need to, take time to write that. My bad. Okay, that's the next thing we're doing is we're calculating initial velocity. Hopefully you guys saw this part up here, 1.53 seconds. Sorry, I didn't flip over. Okay, so let's say that now I give you a delta t. So let's say that I just tell you that it takes 2 seconds to get to the top, to get to its highest point. And I want you to tell me how hard did you have to throw it. Okay, well now this is easy, okay, because VI becomes my question mark and VF is still 0. Okay, so I can take the exact same equation. I can say that VF equals VI minus 9.8 delta t, and now I'm just going to plug in my delta t. So I'm going to plug in 2 there, I'm going to plug in 0 there, and now I'm going to end up with 0 equals VI minus 9.8 times 2. Okay, so when I go and do my 9.8 times 2, let's do that. Okay, so we'll clear and we'll do 9. I don't know why that's happening. 9.8 times 2. I'm going to get 19.6. So now I've got 0 equals VI minus 19.6. So to get VI all by itself, I just have to get that 19.6 out of there by adding it onto both sides. Okay. And so now my VI is going to be 19.6 meters per second. There we go. So there's another thing that I could do. So I can use it to calculate initial velocity, or I can use it to calculate delta t. Now the last thing that we're going to do here, so number 3 is going to be something new. So number 3 is going to be calculate maximum height. Okay, so if an object's going up and back down, how high is it going to go? And we're going to have a brand new equation for maximum height and a brand new variable. So our new equation is this: y max equals 4.9 times delta t squared. It's just that easy, okay? Now, y max equals maximum height. Now, this is really important that you get this written down, okay? Delta t in this instance means time it takes to get to max height. So it's not the total time in the air. It's the time it takes to get to the maximum height once it's thrown. Okay, so let's do one of these. So let's go back up here and look over. I already got it highlighted. Okay, so let's use VI and delta t here. Actually, we don't even need VI. Sorry, that was for an old part. So for this number 1 where it says where we already calculated how long it takes to get to the highest point, delta t is 1.53, so that's how long it takes to get to the highest point. So now all I'm going to do is I'm going to take that delta, I'm going to say delta t equals 1.53. Y max is question mark. And now I'm just going to plug in. So Y max equals 4.9 times 1.53. Let's go do it on the calculator. 4.9 times 1.53, 7.497. So we'll call that 7.5. How about that? Oh, whoa. Psh. Woo, Mr. McSparron, you almost messed up. God dang. You guys got to call me out when I do that. 1.53 squared. Jeez, that would have been really bad. So I got to do 1.53 times 1.53 and then times 4.9. All right, so I'm going to do 1.53 times 1.53, 2.34. So I've got 2.34, that was actually 0.9 times 4.9. Now let's go back and multiply that times 4.9, and 11.47 is what I want to get, okay? So Y max, so the maximum height is 11.47 meters. So that's our new thing, all right? Let's go ahead and make sure that you box that equation in and highlight it. There we go.